नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार धुरी, फैकल्टी ऑफ मेजरमेंट्स। आज हम स्टार्ट कर रहे रिवीजन थ्रू गेट पीवाईक्यूज। रिवीजन थ्रू गेट पीवाईक्यूज हम पढ़ रहे। सो फटाफट अब मेजरमेंट्स में क्या क्या टॉपिक्स है वो डिस्कस करेंगे आज। ओके, सो प्रीवियस में क्या क्या क्वेश्चंस आ चुका है, लेट अस गो थ्रू दैट। फर्स्ट टॉपिक, लेट अस टेक एरर एनालिसिस। एरर एनालिसिस में क्या क्या क्वेश्चंस आ चुका है, या ट्राई टू आंसर दिस क्वेश्चन। जल्दी से जल्दी ये क्वेश्चन को आंसर कर दीजिए बेटा, फटाफट। गेट 2017 का सवाल है बेटा। So let us talk about this question now. How to solve this question? See how to solve this question. The following measurements are obtained on a single load. V is equal to, so what is given? V is equal to 220 volts. So let us take the solution. V is equal to 220 volts plus or minus 1%. Next, I is equal to 5 amperes plus or minus 1%, and the power VW is equal to 555 watts. 555 watts plus or minus 2%. So if the power factor is calculated using these measurements, power factor means what is the formula? Cos phi. So is expecting cos phi. So we know that P is equal to VI into cos phi. So cos phi is equal to P by Vy. But what is the question asked? He is not asking the power factor. What he is asking? So if the power factor is calculated using these measurements, the worst case error in the calculated power factor, he is asking the power factor error. So the error in power factor क्या होगा? Percentage error in power factor क्या होगा? So this percentage error of these all are product of quantities. So 2% plus 1%, 1%. So for product of quantities, the errors percentages will be added. So the right answer for this question is the 4%. Right answer for this question is what? 4%. Gate 2017 का, so 2017 में एक question came. So the right answer for this question is 4%, my dear. Now let us go for next question. Let us go for another question. So what is the answer for this question? So in error analysis we are getting these questions. What is the answer for this question? Make it fast. Try to tell the answer. What is the answer for this question? I am expecting the answer from your side. What is the answer for this question? I am expecting the answer from your side. So this question is related to uncertainty. Suppose explanation, solution. If z is a function of two variables x and y, and x and y are independent to each other, x and y are independent to each other, x and y are independent to each other. Okay, x and y are independent to each other. That is the most important. And the uncertainty in x, is wx, uncertainty in y is wy, uncertainty in z wz. Then the uncertainty in z is given by your function dou z by dou x whole square, uncertainty in x whole square, plus dou z by dou y whole square, uncertainty in y whole square. Okay, so this is the uncertainty in z. Now the same formula we can use. Okay, chalo, we can use the same formula here. Two resistors with nominal resistance values R1 and R2 have additive uncertainties. So what are the additive uncertainties here? This is delta R1, printing mistake. These are delta R2 respectively. So these are delta R1 and this is delta R2 respectively. When these resistors are connected in parallel, the standard deviation of the error in the equivalent resistance R is dash. So it is dou R by dou R1 whole square. So the answer will be, what is the answer? The answer could be dou R by dou R1 whole square, uncertainty in R1 delta R1 whole square, plus dou R by dou R2 whole square and uncertainty in R2 whole square and under root. So that is the uncertainty in R. So that is the uncertainty in R. So option A is the right answer. GATE 2017 question was asked in GATE 2017. Okay, so let us move for the next question. So try to answer this question. What is the answer for this question? GATE 2014. Question is from GATE 2014.
అసలు జనాన్ని బ్రెయిన్ వాష్ చేస్తున్నారా లేదా లక్ష్యాన్ని ప్రదర్శించే ప్రొవైడ్ చేస్తున్నారా?
Answer please. What is asking? Suppose the resistor R1 R2 connected in parallel to give an equivalent resistor R. If resistor R1 and R2 have the tolerance of 1% each, the equivalent resistor R for R resistors. So resistors R1 300 ohms, so this is given as 300 ohms. R2 is given as 200 ohms. So this is 300 ohms. This is 200 ohms. Will have a tolerance of dash. Will have a tolerance of dash is asking. Suppose a resistor R1 and R2 are connected in parallel to give an equivalent resistor R. If resistor R1 and R2 have tolerance of 1% each, so tolerance of 1% each. So what is the meaning of this? So if you solve, solution, R1 is equal to 300 ohms plus or minus 1%, R2 is equal to 200 ohms plus or minus 1%. So what is R he is asking? Okay, we'll have a tolerance of what? So how to solve this question? So we know that 1 by R is equal to 1 by R1 plus 1 by R2, or R is equal to R1 R2 by R1 plus R2. So he's asking the tolerance. So how to find out the tolerance here? Answer please. If when the question is asked in this model, the best way to solve this is we have to go through like this. Okay, so method 1, I will go with the method 1. Method 1 I will go. So R1 is given as how much? 300 plus or minus 1%. Na? So that means 300 plus or minus 1% means 300 plus or minus 3. Next, R2 is given as 200 plus or minus 1% means that is 200 plus or minus 2. Okay, va? 200 plus or minus 2. That means what? It can be either 297, this will 303. Next, this is 198 and 202. Okay, so now what I can take, R is equal to R1 R2 by R1 plus R2. So if you take this 297 and if you take this 198 by 297 plus 198, or you can go with this other one also, 303 into 202 divided by 303 plus 202. So what I am going to get? Use the 𝐂𝐤𝐴. So this is 297 into 198 divided by 297 plus 198. Sorry, 297 into 198 divided by 297 plus 198. So it is 118.8, and this one 303 into 202 divided by 303 plus 202. So it is coming as 121.2. Okay, so how much percentage in R will be coming this? Okay, so generally R should be what? If you take R, if you take general R, so general R will be what? 300 into 200 divided by 300 plus 200. So it is coming as 300 into 200 divided by 500. So it is 120 is coming. So in 120, how much percentage? If you check, 118.8 should come. So this is the true value we have to get, but measurement value is this. Measurement value minus true value by true value. Measurement value minus true value by true value into 100, that is a percentage error. So that means 118.8 minus 120 divided by 120 into 100 is coming around 1%. So in 120, if you take 1%, 1.2, so 120 minus 1.2 and 120 plus 1.2, 121.2. So how to find out this I am telling. So the percentage is asking now, percentage is equal to measurement value minus true value by true value into 100. So if you take the measurement value 1, this is 118.8 minus true value 120 by true value 120 into 100. So it is going to become as 1%. 118.8, if you check, minus 120 divided by 120 into 100. So it is coming as minus 1%. So 1% is the answer. This is the way you have to solve. The method 2, I can go for the partial differentiation method. So what is the method 2? See here. Method 2 is like this. 1 by r is equal to 1 by r1 plus 1 by r2. So now if I do the partial differentiation, minus 1 by r square, this is minus 1 by r1 square with respect to r, though r1 by though r, this is minus 1 by r2 square, though r2 by though r. So minus gets cancelled. So I can write this as 1 by r into r, this is 1 by r1 into r1, though r1 by though r, plus 1 by r2 into r2, though r2 by though r. Okay, so what I can write now? So I can write like this. 1 by r I will write, 1 by r I will take r by r1, 1 second, yeah. So what I will do, this though r I will bring this side, though r by r is equal to r by r1 into though r1 by r1 plus r by r2 into though r2 by r2. This is another way of doing the problem. Okay, try to understand what I have done. I have multiplied with both sides with though r, then this though r gets cancelled, and r I have sent here. So though r by r is equal to r by r1 into though r1 by r1, r by r2 into though r2 by r2. Okay, so what is the concept here? If you multiply with 100, this is percentage in r is equal to r by r1 into percentage in r1 plus r by r2 into percentage in r2. So what is the r? R is this 120 divided by r1. What is the r1? 300. And what is the percentage in this? 1%. Am I right? 1%. And what is this? This is 120, this is 200, and this is also 1%. So now if you simplify, how much you are going to get? If you simplify, how much you are going to get this? %, you are going to get. Simply you are going to get 1%. So this is another method of solving the problem. There are two methods to solve this problem. One method is like taking these values, taking the values plus or minus. Okay, so the resultant I found. So this is the true value actually I should get. Okay, without tolerance. So this is with tolerance, the measurement value. So this is a measurement value minus, this is a measurement value 1, this is a measurement value 2. So this is a true value. So you can take the percentage with any one, you get 1%. This is very simple and your time saving method. Your time will be saved. But here this is what lengthy, but if you can remember this formula, I think all of you understood this formula. If you multiply with both sides with 100, so it is become percentage R. If you multiply this with into 100, this is percentage R1. If you multiply this with 100, this will become percentage R2. So like this. So this is a percentage in R1, this is a percentage in R2. So percentage error in R is equal to R by R1 percentage in R1, R by R2 percentage in R2. So percentage in R1 is equal to 1 and percentage in R2 is equal to 1, like this. Understood, my dear? Chalo. Let us go for one more question. It's a very good question, quality questions. Yeah, answer this question. Question I was asking GATE 2015. So what are the question asked? Instrument type is given this side, used for what? Permanent magnet moving coil, moving iron connected through current transformer, moving iron connected through current transformer, rectifier, electrodynamometer. So try to answer this question. I'm expecting the answer from anyone. Very good question. See here, there are 4 instruments, 1, 2, 3, 4, but here are 3 applications. वो क्या हो गया आंसर? Answer for this question. Nobody is telling. If anybody is in the live, you can answer. So we know very well PMMC is suitable for DC. Okay, PMMC is suitable for DC, and moving iron actually is suitable for both AC and DC. Alone moving iron is suitable for both AC and DC, but this time the moving iron is connected to current transformer. If the moving iron is connected to current transformer, then there is no question of DC. It is suitable only for AC. So Q goes to 2. Next, dynamometer, sure, it is suitable for AC and DC. Rectifier also can be suitable for AC and DC because it is going to average the DC value. So R goes to 3, S goes to 3, P goes to 1, Q goes to 2. So option B is the right answer. Option B is the right answer. Very good question. Third provocative question. Okay, so let us go for the next question. Yeah, try to answer this question. गेट 2019 का सवाल है. Answer please. So what is the question asked? The moving coil instrument having a resistance of 10 ohms gives a full scale deflection of the current when the current is 10 milliamperes. Okay, so we can use as a moving PMMC as a ammeter. So this particular thing we can take it as PMMC ammeter. So how to solve these questions PMMC ammeter? If you check a moving coil instrument having a resistance of 10 ohms, so gives a full scale deflection when the current is 10 milliamperes. What should be the value of series resistance? He's asking the series resistance, so it is a PMMC voltmeter. What is the value of the series resistance so that it can be used as a voltmeter for measuring a potential difference up to 100 volts. So range extension, that means if you take the voltmeter, so this is the VM and this is the RM, but this is our meter. Okay, so in series we are keeping a series resistor. So this is a series resistor. So here I am going to get V. So here I am going to get the capital V. Okay, so how to solve? What is asking? What should be the value of series resistance is asking. So the solution is RSC, series resistance का formula है RM into M minus 1. So where this M can be taken as capital V by small vm minus 1. So in the question, what is mentioned? A moving coil instrument having a resistance of 10 ohms. So this resistance is 10 ohms. Gives a full scale deflection of current 10 milliamperes. So this is 10 milliamperes. So this is 10 milliamperes. What should be the value of series resistance is asking, so that the range he wants to extend up to 100 volts. So what is the value of Vm? So we can take the Vm, this is the Vm, right? So what is the value of Vm? Vm is equal to Im into Rm. So what is the Im? That is 10 milliamperes, 10 into 10 power minus 3, and meter resistance is 10 ohms. So that means 100 millivolts. So he wants to extend this range to 100 millivolts to 100 volts. So meter resistance is 10 ohms. This is 100 volts. 100 millivolts minus 1. this and this gets cancelled. 1000 minus 1, so 9990. So option B is the right answer for this question. Option B is the right answer. 9990. Very good question, because people will think it as ammeter, but the question asked for range extension on the voltmeter. So the correct option is option B. Okay, now let us go for another question. Try to answer this question. GATE 2013 का सवाल. So if you see here, you are going to see the rectifier here. So rectifier will give you the average value. So this is a 1 kilo ohm. There is another resistor here. This is 100 kilo ohms. This 100 kilo ohms is a resistor here. So let us take, this is R1, this is R2. But what is the voltage we are going to measure? Voltmeter. This voltmeter is PMMC. Okay. So PMMC measures always the average value. Am I right or not? So what is the average value? The average value is nothing but Vm by pi. For a V average value is nothing but Vm by pi. So V average here is equal to Vm by pi. The voltage available here after the rectifier will be V average. So V average will be Vm by pi. Okay, Vm by pi. Am I right or not? So if these two resistors are in series, so what is the question asked? The input impedance of the permanent magnet moving coil is infinite. Assuming that the diode shown in the figure below is ideal, so the voltage across this diode will be that. Okay, so what is the voltage available there? V0. Okay, half wave rectifier circuit now. The voltage across 100 kilo ohms is the average output voltage. That is the reading of the voltmeter. So what is the reading of the voltmeter we can take? So the V0 I can take it as this resistance 100 kilo ohms divided by 100 kilo ohms plus this 1 kilo ohm into V average. Okay, so what happens now? This is 100 kilo ohms and this is 101 kilo ohms. V average is equal to Vm by pi. So what is the Vm? That is V peak. There is a 14.14. So 100 by 101 into 14.14 divided by pi. So what is the answer? You check it by using the calculator. See, first follow RM by. अब तक आपने कुछ भी रिप्लाई नहीं दिया, अभी आया, अभी आके you are asking this. I am waiting for the response from any one student. I waited almost from session 2 o'clock को start हो गया, अभी 2:42 हो रहा है. The time is very precious. Okay, whatever the questions are allotted, I am doing that. Okay, I am doing the PYQs. So try to understand that. 100 divided by 101 into 14.14 divided by 3.14 is coming around how much? 4.456. So option A is the right answer. So he is asking the voltage across this voltmeter voltage. Voltmeter voltage means this voltage. This voltage means R2 by R1 plus R2 into supply. But what is that voltage we are going to get? This voltage. The V average will be available. V average is nothing but Vm by pi. Okay, va? So this voltage only we are going to measure. This voltage is V0. Is it clear? RM? So answer is 4.46. Okay. I'm not aware. Chalo. Session started 2 o'clock, my dear. So try to answer this question. Make it fast. A 0 to 1 ampere moving iron ammeter has an internal resistance of 50 milliohms and inductance of 0.1 millihenry. A shunt coil is connected to extend its range to 0 to 10 amperes for all operating frequencies. The time constant in milliseconds and resistance in milliohms of shunt coil respectively are dash. So try to solve. I'm waiting for the response. Try to answer this question. A 0 to 1 ampere moving iron ammeter has an internal resistance of 50 milliohms and inductance of 0.1 millihenry. A shunt coil is connected to extend its range to 0 to 10 ampere for all operating frequencies. The time constant milliseconds and resistance in milliohms of the shunt coil respectively are dash. So how to do this? First of all, you have to draw the diagram of this. So this is the moving coil diagram IM. In addition to this, we'll be having one resistance RM and this is LM. Okay. So in parallel, we are going to attach the shunt resistance and shunt component. So RSH and LSH. So this is the total current I. This is the ISH. So what is the data he has given? Let us see now. A 0 to 1 ampere moving iron. So this is 1 ampere. Has an internal resistance of 50 milliohms. This is 50 milliohms. And inductance of 0.1 millihenry. This is 0.1 millihenry. Next, a shunt coil is connected to extend its range to 0 to 10 amperes. So this is 10 amperes. For all operating frequencies, the time constant is asking and the shunt resistance is asking. So we can take RSH is equal to Rm by M minus 1. Rm by M minus 1. So where M is equal to I by Im minus 1. I by Im minus 1. So Rm is what? This is 50 milliohms. So 50 into 10 power minus 3. And capital I is equal to 10 amperes. And Im, that is 1 ampere minus 1. So 50 by 9. So what is answer? So that is 5.55 milliohms. This is 5.55 milliohms. And the time constant is Lm by Rm. Time constant is Lm by Rm. So Lm by Rm means 0.1 milli by 50. So 1 by, that is 2 milliseconds. So the right answer is 2 milliseconds and 5.55 milliohms. So option A is the right answer for this question. Are you there? I'm not able to see any chart here. Chalo, let us go for the next question. So try to answer this question. A 0 to 50 amperes moving coil ammeter has a voltage drop of 0.1 volts across its terminals. At full scale deflection, the external shunt resistance needed to extend its range to 0 to 500 amperes. So how to solve this question? So we can take again the same concept. So this is our Im, this is our Rm. Okay, this is shunt is asking. So this is our RSH. So this is RSH, this is I, this is Im, this is Rm. So this is ISH. Okay. 0 to 50 amperes moving coil ammeter. So this is 50. Sorry. This is 50 amperes. Is asking the external shunt resistance now. So directly we can, so by using the formula RSH is equal to Rm by M minus 1. I can use it, right? So Rm is how much? He has given the Vm, the voltage drop he has given here. So Vm is equal to Im into Rm. So this is 0.1 volt. Okay. Im is the 50 amperes. So this is the Rm. So what is the Rm? 0.1 by 50. Am I right? क्या हो रहा है भैया? 0 to 50 amperes coil ammeter voltage drop is given 1 by 500. So it is going to become 2 milliohms. So this is 2 milliohms. And what is M? Capital I by small m. Capital I is equal to 500 and this is 50 minus 1. So 2 by 9 is going to become 2 by 9 into 10 power minus 3. So what is the answer? कैलसी यूज करके बताओ. Point 222 milliohms. So the right answer is 0.222 milliohms. Okay, let's go for the next question. Try to answer this question. GATE 2012 saval. Hello, life enjoy someone. Okay, try to answer the question. Answer please. So PMMC measures the average value, right? Sorry, but this is not PMMC, right? This is a periodic volt waveform is observed on an oscilloscope across a load is shown. A permanent moving coil meter is connected across the same load. What is the average value? So what is the average value? So we have to know the average value, right? So what is the V average? That I can take 1 by t integration of 0 to t V of t dt. Okay, so in this question t is 20, okay, 20 milliseconds, and 1 by t integration from this one function, this another function, this another function. So how to write? First 0 to, this is 0 to 10. So 0 to 10 is a ramp signal, so that is t dt. Next one is plus or minus minus. So minus, that is 10 to 12. 10 to 12. So what is the amplitude of that signal? The amplitude of the signal is 5 dt. Next plus. Next one is positive. Amplitude is 12 to 20. So 12 to 20. So 5 dt. So that's it. So please solve. What is the answer you are going to get? Please tell me. So how much it will be? 1 by 20. This is t square by 2, 0 to 10 minus 5t 10 to 12 plus 5t 12 to 20. So 1 by 20, 100 by 2 minus 5, 12 minus 2, 12 minus 10, that is 2 plus this is 20 minus 12. So what is the answer? So this is 50 minus 10 plus 40 divided by 20. The right answer is 4. So V average I am going to get as 4 volts. So the correct answer for this question is what? 4 volts. Life enjoys someone. What is the answer? 4 volts. So the right answer for this question is 4 volts. Option A is the right answer. 4 volts is the right answer. So let us go for another question. Yeah. Try to answer this question. GATE 2014 ka question. Try to answer this question. I'm sorry, you're not getting audio. Now you're getting the audio. So gate 2010 सवाल. The Maxwell's bridge shown in the figure is at balance. The parameters of the inductive coil are dash. So this is a Maxwell inductance bridge. So Maxwell inductance bridge, this is R3, this is R2, this is, so how to solve this? So you can keep this bridge in the a bridge mode. That means I can take like this. The same thing I can take like this. So how to answer this? So I can take the test coil like this. So these are test coil. Test coil is resistor and inductor. So these are test coil. So this is the resistor and this is the inductor test coil. And here we are having R2, here we are having R3. So this is another resistor. This is another resistor. And here there is a parallel combination. So what is a parallel combination? R4 and omega C4. So this is R4 and this is C4. So this is a R4, this is the C4. Okay, so this is a bridge and this is the AC supply. This is the AC supply. So this is the detector. So it is a Maxwell inductance capacitance bridge. Maxwell inductance capacitance bridge. So what is the question asked? The Maxwell bridge shown the figure at balance. What are the parameters? So if you take the parameters, this is R1, this is L1, this is R2, this is R3. So I can take at balance, I can take Z1, Z4 is equal to Z2, Z3. So if you solve, you are going to get the concept. So this we can take it as R1 plus J omega L1. Z4 is this R4 into 1 by J omega C4 by R4 plus 1 by J omega C4. R4 by 1 plus J omega R4 C4 and Z2 Z3 is R2 R3. Definitely R2 R3 by R4 should come. So R2 R3 by R4. So right is, so this cannot be the right answer from the options. This inductance cannot be this. So option B can be cancelled. R2 R3 by something should come. So this is also not right. L cannot be the inductance resistance term. So option A is the right answer. Option A is the right answer for this particular question. Okay, so let us go for next question. Try to answer this question. Okay, try to answer this question. First answer this question. गेट 2008 सवाल है. Chalo, what is the way to answer this question? So if you see here, the AC bit shown in the figure is used for measure the impedance Z. If the bridge is balanced for oscillator frequency 2 kHz, then the impedance Z will be dash. Always remember here, this is the inductive, right? So this inductive portion is compensated with this capacitive portion, means definitely this must be resistor. There should not be any imaginary part. So option A is the right answer. Directly we can tell the answer. The answer should not contain any imaginary part. It should be resistor. It should be only resistor. It should be only resistor. Why? Because a resistor in series, a inductor in series is opposite में a capacitor in series. Inductor in series opposite capacitor in series. So definitely what happens now? So this compensation will happen. This will be compensated. So now two resistors are there in the picture. So one resistance we can find it out. One of the resistance. So when I say resistance, it's imaginary part should not be there, right? A plus JB, J part should be 0. So option A is the right answer for this question. If you want, you can solve it, but it's a lengthy process. Yeah. So let us go for the answers. What is the answer for this question? Answer for this question. What is the answer? Question is related to wattmeter. Question is related to wattmeter. Power measurement wattmeter. So what is the given here? A low power factor wattmeter with a power factor of 0.2 having 3 voltage settings, 300 volts, 150 volts and 75 volts, and 2 current settings, 5 amperes and 10 amperes. The full scale reading is 150. If the wattmeter is used with 150 volts voltage setting and 10 amperes current setting, the multiplying factor of the wattmeter is dash. So in the previous problems we have seen the range extension of ammeter, range extension of voltmeter. So there we have seen the multiplying factor. Okay, but here when it comes to the picture of wattmeter, what is the multiplying factor? Okay, so let us see here. What is the multiplying factor for ammeter? What is the multiplying factor for voltmeter? Generally, multiplying factor for ammeter, that is I by Im. This is for ammeter. Multiplying factor for voltmeter, that is V by Vm. This is for voltmeter. Similarly, multiplying factor of wattmeter will be capital W by Wm. So this is the range to be extended. This is the range to be extended. This is the full scale value of the meter. Full scale value of meter. So how to do now? So in this question, he is using power factor 0.2 having 3 voltage settings. So what are the 3 voltage settings? 300 volts, this is 150 volts, this is 75 volts. And the current settings, what are the current settings? 5 amperes and 10 amperes. The full scale reading is 150. Okay, that's good. If the wattmeter is used with 150 volt settings and 10 amperes current, the multiplying factor is what? So W means what? W means full range, that is 300 volts and 10 amperes. So that is 300 into 10 into cos phi. What is the cos phi? 0.2. Okay, so what is the full scale value? The full scale value means it is 150 into 10 into 0.2. So what is the multiplying factor? Multiplying factor is equal to this by this. Full scale value. So that is 300 into 10 into 0.2 divided by 150 into 10 into 0.2. So what happens now? This gets cancelled. So answer will be 2. The right answer is multiplying factor is 2. So let us go for the next question. Try to answer this question. Try to answer this question. Answer this question. Thank you, Neem Sangvi, thank you very much. Try to answer this question. Answer this question. Answer this question. A periodic waveform observed across a load is represented by this formula. V of t is equal to 1 plus sin omega t minus 1 plus sin omega t. Omega t is greater than 0, less than 6 pi, and is greater than 6 pi, less than 12 pi. The measured value using moving iron voltmeter connected across the load is dash. So it is somewhat network theory question, but somewhat mathematics oriented question. So moving iron meter measures the RMS value, right? So what is the VRMS? So that is a VRMS is equal to 1 by t integration of 0 to t V of t whole square dt. Am I right? So that is the function we are going to have. Okay, that is the function we are going to have. So here what is mentioned? V of t. The V of t is given as what? 1 plus sin omega t here. This is given as V of t is given as 1 plus sin omega t here. So this is 1 plus sine omega t, which is greater than 0, less than 6 pi, greater than 0, less than 6 pi. Next, if you check this, minus 1 plus sine omega t, which is greater than 6 pi, less than 12 pi, less than 12 pi, greater than 6 pi, less than 12 pi. So how to solve this question? So I can write 1 by t, t is equal to total cycle 12 pi. For up to 6 pi it is a positive signal, up to some minus 12 pi it is a negative signal. So how to write this? So total 1 by 12 pi, 1 by 12 pi integration of 0 to 6 pi 1 plus sine omega t whole square into dt plus, next 6 pi to 12 pi, 6 pi to 12 pi, that is minus 1 plus sine omega t whole square dt. So this is the expression, so we have to simplify it first. So simplification, this is a mass, pure mass, so you can do the maths. I think you are familiar in the maths. So 0 to 6 pi, so this is 1 plus, this is sine square omega t plus, this is 2 sine omega t into dt plus 6 pi to 12 pi 1 plus sine square omega t minus 2 sine omega t into dt. So how to solve this? You have to do maths. Simplify this. How much you are going to get? This is 1 by 12 pi dt, that is 6 pi. Next, sine omega t term will become 0. Yes. So this sine square omega t I can write as 1 minus cos 2 omega t by 2 integration 0 to 6 pi. Am I right? 1 minus cos 2 omega t by 2. Why? Because sine term will become 0. So this only will be having 1 minus cos 2 omega t. So sorry, 2 sine omega t, right? So sine square theta I can write it as 1 minus cos 2 theta. So this I can write as 1 minus cos 2 omega t by 2. I can write now sine square theta. Sine square theta I can write as 1 minus sine square theta I can write 1 minus cos theta by 2. Okay, so for that I have to apply the integrations. So this I can write, so 0 to 6 pi into dt, and this term will become 0, sine term. Next, sorry, plus this one 6 pi now. So this is one term. If you take this is again dt, so 12 pi minus 6 pi, this will become 6 pi. Next, sine square means I can write 1 minus cos 2 omega 2 by 2 integration 0 to 6 pi to 12 pi. This term will become 0. This term will become 0. Okay, so now what I am going to get? 1 minus cos 2 omega by 2 this. So what I am going to get? 12 pi plus this, both will get 6 pi. So this is 6 pi, this is 6 pi. So 1 by 12 pi, 6 pi plus 6 pi, and this will be how much? 1 minus cos 2 omega 2 by 2 into dt. So if you simplify that, I am going to get as 6 pi. So these two. So please simplify this and this. If you simplify, you are going to get 6 pi. So what is the answer? 12 pi gets cancelled. So what is the answer? 18 pi by 12 pi. So this is 18 pi by 12 pi. So 18 pi by 12 pi. So pi gets cancelled. So 3 by 2 is the answer, right? Option C is the right answer for this question. One second. This is not correct. This is VRMS now. VRMS means square root will be there. We have forgot. Square root will be there. So this entire thing, if you take in the square root, this entire thing we have to take in the square root, right? So this we have to take in the square root of this. So we have to take the square root of all those things. Everywhere square root, everywhere square root, everywhere square root, everywhere square root. So the answer is root 3 by 2. So the right answer is root 3 by 2. Option A is the right answer. Okay, so let us go for the next question. What is the answer for this question? गेट 2014 का सवाल है. So what is the answer? The sawtooth waveform VRMS. So it is connected to moving iron, right? So moving iron means VRMS. So VRMS is equal to Vm by root 3. So 100 by root 3 is the answer. I think 57 point something will come. It's coming around 57.73. Okay, 57.73. Nivi Sangvi, where are you from? Where are you from? Okay. Chalo. Answer this. Two wattmeter method is used for measurement of power in a balanced three-phase load supplied from a balanced three-phase system. One of the wattmeter readings half of the other. So let us take one of the wattmeter readings is half of the other. Okay, something like this. Okay, if one of the wattmeter is half of the other, then the power factor is what? So how to solve this? How to solve this? So I can take this formula, tan phi is equal to root 3 into W1 minus W2 divided by W1 plus W2. Okay, so this is root 3, this W1 something, and what is this W2? Half of the W1 divided by W1, and what is the W2? Half of the W1. So this will become as 1 by 2 W1 divided by 3 by 2 W1, 1 by 2 into 2 by 3, so 1 by root 3. So 5 will be 30. 5 will be 30. So power factor is cos phi. Cos phi. So cos 30. Root 3 by 2. Root 3 by 2. 1.732 by 2. It is going to come as 0.866. So option D is the right answer. Okay. Answer this question. What is the answer here? Power consumed by a balanced three-phase three-wire load is measured by two wattmeter method. The first wattmeter reads twice of the second, and the load impedance angle in the radians is what? So first wattmeter W1 is 2 times of the W2. So what I can write? Tan phi I can write, that is root 3 into W1 minus W2 divided by W1 plus W2. So this I can write it as 2W2 minus W2 divided by 2W2 plus W2. So this is root 3 into 2W2 minus W2, that is W2 divided by this is 3W2. So it is going to become as 1 by root 3. So phi is going to come as how much? 30 degrees. But is asking the radians. 360 degrees is equal to 2 pi radians. So 1 degree is equal to 2 pi by 360. So that is pi by 180. So radians. So answer will be pi by 6 radians. Pi by 6 radians. That's it. Pi by 6 radians is the answer. Let us go for the next question. GATE 2014 में 2 questions आ गए. So please try to answer this question. Answer for this question. What is the answer? 2014 का सवाल. So directly we can use the formula. Tan phi is equal to root 3 W1 minus I can check. This is W1 minus W2. 100 watts and 250 watts. So this is 100 minus 250 divided by 100 plus 250. So will be root 3 into 100 minus 250 divided by 350. That is coming as minus 3 by 7 into root 3. Shift tan inverse of answer. I'm getting as 36.5. So phi is equal to 36.5. Phi is equal to 36.6. So cos phi, what is the power factor? So cos of answer is 0.802. 0.802. 0.802. That is the power factor. 0.802 is the power factor. Okay, let us go for the other question. Try to solve this question. GATE 2009. answer this question. The figure shows a three-phase delta connected load. So there is a delta connected load Z1, Z2, Z3. In the place of Z3 is a pressure coil is coming, the current coil is coming. 400 load supplied from a 400 volts three-phase balanced source. The pressure coil and current coil of a wattmeter are connected to the load as shown. With the coil polarity suitably selected to ensure a positive deflection, the wattmeter readings will be dash. Try to answer this question. GATE 2009. So we require the voltage across the potential coil, we require the current passing through the current coil. So we require VPC, VPC comes from VBC. So VBC, how to get it? He has given 400 volts. Try to answer. VAB, VBC, VCA if you take. Try to answer. So kaisa kal karna? So we need the wattmeter reading, right? Wattmeter reading means what? Power. Power means VPC, ICC, cos of phi. So in the picture VPC means what? In the picture VPC means pressure coil, that is VBC. Next, in the picture what is ICC? This is ICC, current pass in the current coil. So that is ICC is equal to VAC by Z. So now if you check what he has given, 400 volts. Okay. So here let us take the reference voltage as 400 volts, VAB, VBC, VCA. So if you check these voltages, so this is the VAB reference I will take. So this is a VAB reference I will take. So this is a VBB reference I will take. This is a VCA reference I will take. So this is a VAB. So this is a VBC and this is a VCA. So what is a VPC? If you check, it is having a phase shift of how much? Minus 120 degrees. So if VAB is taken as 400 with 0 degrees, VBC will be taken as 400 with minus 120 and VCA will be taken as 400 with plus 120. Okay, so we got the VBC. So what is ICC? ICC is nothing but VAC by Z. So this is VCA 400 plus 120. So this will become 400 plus 120. Z kitna hai? Z is this 100. Am I right? So it is going to become as how much? 4. So we need the power factor angle. So we got the VPC is equal to VBC. So we got the VBC. This is our VBC. This is our ICC. ICC we got it. And what is the cos phi? That is the angle between VPC and ICC. That is VBC and ICC. So what is answer? So 400 into 4. We average power 400 by root 2. 400 by root 2 into 4 by root 2. That is answer 800. So this is 400 by root 2 into 4 by root 2. So answer is 1600 by 2. So 800 watts is the right answer. So 800 watts is the right answer. Got it? So these are some good questions asked in the previous years. So don't miss these questions. Enough for today. I wish you all the best. Okay, thank you.